Danny is the VP of AI and Machine Learning at Unity Technologies. And he'll be talking about democratizing access to superior technology with machine learning agents. Please welcome Danny to the stage.
Hey, good morning. I'm very excited being here, looking forward to this event and this venue. I'm going to talk about machine learning in the enterprise, so don't get scared about me representing Unity here, a gaming company, because before working for Unity, I was head of machine learning at Uber, where I rolled out a company-wide machine learning platform called Michelangelo. Before that, I was general manager for machine learning at Amazon, where I ran the Elastic machine learning service for all of Amazon, and I also launched the very first machine learning service on AWS. And I also spent time at Microsoft for years and IBM. Getting back to Unity briefly, just if you don't know Unity, I have to put a pitch in here very quickly. It's basically a game development platform. It's also a film platform and automotive platform. We have about 60% of the market in gaming. Over 3 billion devices, about 1.5 billion players every month playing a game on the Unity platform. So pretty interesting technology there. What I'm really going to focus on today is the enterprise side of it. I'm going to talk a bit about how companies like Uber and Amazon, why they're so successful. Yeah. And they live in a world of lower prices, faster delivery, and all these usual things that we see in a modern enterprise. Does anyone have an idea how many products, for instance, Amazon has in their catalog? They have over 1 billion products, 1 billion SKUs in their catalog, adding about 500,000 new products weekly. Yeah? Yet they can deliver some of those products in less than 60 minutes. Yeah? So how do they do that? Why are they eating the world? Well, that's because they very quickly, almost from the beginning, realized that this way of writing software to run your business just doesn't work. Yeah? You hire these all-knowing programmers and they write some deterministic software. They live in a Newtonian world where they think that everything is deterministic and fixed. Yeah? Very early on, these companies realized that they live in a different world. Yeah? They live in a world where we have learning algorithms, we have data, building models, and basically making predictions day long. Yeah? So it's all about distributions of probabilities. Yeah? So they live in a Heisenberg's world, yeah? In a world of statistics and distributions of probabilities. Yeah? That's the big deal. Companies who think they can figure it all out and implement it, they're wrong. Yeah? And that's why you see Uber and Amazon being so successful. Yeah? So very, very quickly, I don't want to go into the history here from Shannon's chess algorithm up to AlphaGo. What I want to point out is the shift. From early on, AI was all about very tailored custom hardware, custom software. The brilliance was in the chess algorithm for Shannon, yeah? What happens around 2016 with AlphaGo is that we started using reinforcement learning, which is, learning from scratch without human interaction. We use commodity hardware and software. It's really a very, very important shift. And that's what I'm going to talk a bit about today. So why Unity? Well, I think Demis Hassabis put it really well a couple of weeks ago when he said that when we announced our collaboration between Unity and DeepMind, that you can really use these game environments to crack the code needed to solve real-world problems. Yeah? And trust me, I have been in the world of real-world problems, and it's really, really hard to crack the code because you think in a certain way when you are in the enterprise and are looking at this these real-world problems. Yeah, in a game world, it's so different. Yeah, so let's quickly look at nature's way of learning, because that's the key I'm going to talk about today. Yeah, which is about observing, take action, take the reward or the penalty, and essentially learn from random exploration all the way to the point where you can exploit, yeah? I'm going to show you a small example here that we did, yeah? So we basically have a chicken, we have gift packages, and the chicken can take some actions, yeah? Go left, right, forward, backward, yeah? And it can either get hit by a car, which is bad, and it can collect a gift package, which is good, yeah? So see this in sort of a business context. These are opportunities and challenges, yeah? And then let it train from scratch. We call that tabula rasa, yeah? It has no idea, there's no human input here. Here you see it moving more backwards than forwards, yeah? After an hour of training, by trial and error, it figures out to be pretty good at moving along. Still, it gets hit by a car. Do you know why it's moving forward? Because I never told it to move forward. Well, it's always trying to find more gift packages in the future, yeah? So, after 6 hours of training, yeah, it becomes superhuman, yeah? It's unstoppable, yeah? It will not get hit by a car, it will pick up these gift packages, yeah? So you have a complete generic learning algorithm, learning from scratch by trial and error, and it gets really good at it, yeah? This is the same as Jeff Bezos trying to figure out how to get you to buy more, yeah? Yeah? It is, yeah? Truly. Yeah? I'll show you some quick examples. Here we have quadrupeds. Same algorithm, same learning algorithm, but it can, you know, it can be the chicken crossing the road, or it can be a quadruped learning to walk, yeah? Or it can be two tennis players playing with each other, yeah? Again, same algorithm, no human input, it's just trial and error. I want to show you one fun one from early in the year. We were inspired by the World Cup, yeah? In this case, we have two agents. Yeah? We have an offensive, a defensive player. We put them together, and this is what comes out, yeah? The defensive player becomes a goalie, and the offensive player is trying to score at the other end all the time, yeah? Very simple reward system. And you see behavior that we as humans look at and say, huh, I have seen this before, yeah? Apparently, this is how you play if you're defensive, yeah? You stand in front of the goal and defend it, yeah? Curriculum learning is an example of learning that also has some relationship to animals and humans, which is if you want to solve a really hard problem, you solve it by step. So you have an easy problem, and then you graduate to a harder problem. In this case here, the agent learns to use the orange cube. When the wall is too high to scale directly, it can jump on the cube and then scale the wall, yeah? I'm gonna skip this one. Imitation learning is another one. This is on the left side. On the left side is a human playing. On the right side is the computer looking over the shoulder of the human and trying to figure out how to play this game, yeah? And you see it still crashes after 15 seconds, but I can tell you after 25 seconds of looking over the other player's shoulder, it does not crash any longer. And after 5 minutes looking over a single human player, it gets as good, it converges and gets as good as the human player, yeah? So this is an example of memory. The agent comes in, we only punish it in the sense that we tell it whether it took the right exit or not. It should take the exit with the right color, yeah? We don't even tell it what to look for. We don't tell it it's the color that matters. It learns to remember the color of that first brick when it comes in, yeah? So it's an example of working memory. Again, a thing that, trust me, that can be used in enterprise relationships where this is, you are learning what matters for your customer, yeah? I want to show this fun one here. It's just for the fun of it. You can even have a humanoid learn to walk, yeah? Let me talk something important, because this is really the key of my presentation, which is that looking at extrinsic values is basically something about game scores. So you saw the chicken, yeah? It's don't get killed, don't get hit by a car, that's negative. Collect gift packages, that's positive, yeah? It's specific to the environment, and it's really what we think about when we sort of want to get rich, yeah? It's this external thing, yeah? But there's also an intrinsic component, and we call that agency. It's things like curiosity, impatience, even love. When did you hear that word in an enterprise presentation? Yeah, those things were invented by nature because they are important in learning, and they're important to learn to survive. Yeah, so I'm going to give you some examples here of how an intrinsic value is important. I often talk about the Agatha Christie event chain when we're in reinforcement learning. It's basically when you have to learn something that is so improbable. It's so improbable that the computer is going to figure out these weird relationships. Yeah. So let me give an example that an agent needs to go from room to room and find a push button in a room. Push that button, a pyramid will appear in another room. On top of that pyramid is a gold coin. You need to hit the pyramid to collect the coin, yeah? It's just not going to happen randomly. You're never, the computer will never, or the algorithm will never learn that relationship, yeah? So that's why we add something that we call curiosity, yeah? And I just want to say that curiosity is a very sort of emotional thing, but I don't have time today, but I could go through the mathematics behind it, yeah? You can basically formulate curiosity as making really bad predictions, yeah? You maximize your bad predictions. You look at something and you don't know, you guess wrong, and then you try it and it's very, very different, yeah? That's curiosity, yeah? And here is an example of an agent that's not curious. It's just random and is never really figuring anything out. It's just moving around, yeah? Here's an example of an agent that is all curious, but it has no external, it's not trying to get rich, it's not trying to collect anything, it's just exploring, yeah? And in this last example, we put it together and say, get rich and be curious. And what happens is that it gets really, really smart at finding relationships, and it figures out how to go from room to room, find the button, push the button, find the pyramid, knock it over, and get the gold cube, yeah? But think about that in a product recommendation setting, yeah? Imagine today, what we're doing today in product recommendations is there's complete show random products, and over time, we learn what the customer wants, yeah? Randomly. But what if we could learn that, you know, if I sell you a barbecue book, you would buy a gas grill, and if you buy a gas grill, you're going to buy this and that, and you're going to have all these things are going to be connected, yeah? What if we implemented curiosity in our recommendation algorithms, yeah? I want to finish up on a fun note. Let me introduce you to Poppo. Poppo is a virtual robot puppy. You see it has engines and in its joints, and it's essentially a virtual character that has to learn to walk, run, jump, everything, yeah? There's no game developer, there's no software engineer here who says, this is how this dog needs to operate, yeah? And the only reward here is actually return the stick to me, yeah? And we will send the dog and its twin dogs in training camp, and they will, you know, try out for 1,000,000 times. And as you can see, they have a hard time walking, but they will learn to walk, run, jump, turn. They will learn to do all these things because they're needed to go and fetch the stick, yeah? Okay? So we do this in a computer, and we do it parallel so that we don't have to wait too long time. And then, when we're done, this is what it looks like, yeah? So you see Poppo here, basically doing all this without human touch, yeah? This is learned from end to end, yeah? So I throw the stick with the mouse, and you see learned behavior, yeah? Watch here, actually, there's one example here. Whoops, It's falling over, yeah? Puppies, they do that. There's a piece of art here, and you know what that is? That is to stop the training while it's still a puppy and not a super dog, yeah? So it's very important to understand that playing around with these algorithms in a game setting pushes the limit, yeah? As Demis Hassabit said, this is a very, very good way of cracking the real code for the real problems, yeah? I want to show you for fun. You can take a TensorFlow model and train, and then you can put it on an iPhone, on Android. You can actually put it on any of the 32 platforms we support, and then it's right there, yeah? All these environments, we talked about democratization in the title, all these environments that I showed you are available. All the code is open source, and anyone can go to GitHub and download it and play around with it. It's something that's actually very easy to use, and for researchers and also for enterprise folks, it's a way of trying out these algorithms and get ideas. I did do this presentation 2 months ago to a French company, and they came back 2 months later and said they have now put a group of people in their recommendation team to explore Curiosity to see if they can better get to know what makes the customer buy different products. So that was all for now, right on time. Thank you for listening. And
Thank you, Danny. That was a fascinating presentation. Let me just kick off by, you mentioned using the game environment to solve real-life problems. And today is the International Day of the Girl. And it made me think, have you sort of used or thought of using gamification and the game environment to solve thorny issues like gender diversity?
yeah, of course we think about that. And we think that it's very important to think about these games in a bigger context. It's not just about destroying or first-person shooter. It's about using these games to explore deep values. I mentioned curiosity as one of them. It's very interesting. We found that if we put a Netflix console or TV in one of those rooms in the house, because of curiosity, the agents get stuck in front of Netflix and just watch, one show after the other show because there's always a new show to watch, yeah? So in that sense, you look at it and say, curiosity is not all we need. We also need something like, I get bored or I have impatience. I think all those values address a wider range of developers to get into the game, yeah. Pun intended. Yeah.
Great. I would like to open up to questions from the audience. If you would like a question, you can put up your hand. Could we have the mic here, please? If you could just say your name, your organization, and then the question.
Hello, Eugene, startup founder. My question, like in your all examples of like that game of where chicken is crossing a road, like how hard would it be to train a model to avoid obstacles if they are some kind of dynamic ones? Because all cars are always in the same position at a certain time. But would it be...
Actually, the cars are coming in randomly.
Oh, randomly.
So actually, at any given moment...
So each try is dynamic.
Yeah. So it's actually it's very important. It's a very good question because it allows me to make a point, which is that the power of these learning algorithms, the power is that they learn to generalize. So that even though they see a situation they haven't quite seen before, they get really good at handling it. So these vehicles are coming in completely random. So you can actually prove that at any given moment, it's facing a situation it's never seen before, but it has seen something really close to it and knows how to deal with it. So again, think about a distribution, not a single shop solution, but a distribution of solutions.
Great, thank you. We have a couple more questions there.
My name is Johan, and I'm from Leapion Analytics. My question is regarding how to simulate those worlds. So with computer games, it's rather easy because you can decide what the world looks like. But in our world, it's tough to just put in some parameters and say, this is how the world works. So how do you take the gaming environment and apply it in a much more complex world?
You're spot on. In a much more complex world, the real world, there are a couple of things in play. One of them is that we have a lot of data in that real world, so we can use those data to actually train on. Yeah? We can also use those data to start making some assumptions about our customer, make some assumptions about our supply chain, and start simulating, based on those learnings, start simulating our supply chain. And as I mentioned, with the model, even if your simulation is not spot on a copy of the real world, the model generalizes and will also, in many cases, work efficiently in the real world. We talk about, when we run these simulations, we talk about what we call the reality gap. So the difference between being synthetic, say that you train a robot in a computer, but the physical robot is going to be slightly different from the model in the computer, yeah? And what we do is that in the computer, we basically add noise. We fluctuate gravity all the time, we fluctuate friction all the time, and by adding noise to the simulation, you create a more robust model that when you bring it into the real world, and we have examples of that, it works directly from synthetic training to a physical robot. It works because the model generalizes and can handle reality as long as it's just within that distribution.
Sounds good. I think we have time for one last question. I saw another hand over there.
Yeah, hi, I'm Satya from HCL. My question was about at the point which you made right at the end when you said, you know, the important point is stopping the dog from becoming a super dog. So I was curious to know, how would you do that? Because you're reintroducing human perception there and again, variability.
Oh, I love this question. Yep. So in another presentation where I show some other things, I say the chicken is Jeff Bezos because it's sort of looking for these opportunities and avoiding the dangers, the challenges, yeah? And I compare the dog a bit to Facebook, where they went to the super dog level and it figures out that it can just bite my leg off and keep the stick, yeah? It takes over. And that's because you have to be really, really careful when you do this, what kind of reward system you set up. Because if you set up a reward system that's, for instance, like, let's squeeze every single dollar out of the customer, you know what's going to happen? Yeah? The customer is going to run away, yeah? So you have to formulate your reward system that you train after. You have to be really smart at that. It's much harder than just coding because you have to instill deep values, your company values, in those rewards. Yeah? So for instance, at Amazon, they actually never, and I know it, they never look at the profit when they sell to you. They only look at the probability of you actually clicking buy. Yeah? In that way, they always try to put you first and not their own profit. Fortunately for them, the profit just follows. Yeah? But they're not trying to squeeze you. They're just trying to sell to you. Yeah.
Sounds good. I'm afraid we don't have time for any more questions, but I saw a lot of hands in the audience, but I hope they can find you afterwards.
Thank you
very much, Danny. It's a pleasure having you here.